speaker. Our next speaker, he is Dr. Bastola. He is a professor from UNO, civil engineer. I'm actually taking a class with him right now, Principles in Sustainability. And Dr. Bastola have a lot of experience with water. He has research interest with the study of terrestrial water cycle of a medium to large river basins. He have been working with interaction of hydrogeolicals and biochemical processes. He have also assessing the impact of climate and global change on water resources and hazards and hydrologic regimens. He have studies in influence of vegetation of soil erosion and shallow land slides and gully erosion. He have been teaching several courses um, on water resources and is included teaching in natural hazard mitigation modeling, in coastal engineering and coastal hydraulic structure and sustainability principles. He's also a member of the American and European Geophysical Union, and he is just a great person. So, Dr. Bastola, we're thankful for have you here, and the mic is yours. Thank you.
Thank you, Alejandro. Thank you for a nice presentation. Thank you all for joining this presentation. This is Satish Bastola. I'm from University of New Orleans. And I would like to thank the organizing committee for giving me this opportunity to talk about the climate change and water resources to very important the topic, very important topic and very relevant topic in today's context. Water is because this is the foundation of sustainable development, and climate change is because it poses the largest environmental threat that we humans have seen. And talking about the context, Louisiana, Lindsay, she put very nicely the context related to the Louisiana, so I'm not going to repeat about it, but I'm just going to go through very basic topics and what I mean by sustainability and how climate change and sustainability are interconnected. Uh, so, so the water resources, when you talk about water resources is not a finite resources. We don't have any connection to our outer spaces. Whatever we have, it is limited resources. But depending upon how we manage it, these water resources can be a renewable resources. The water is used for wide range of systems, food, energy, and water systems. And these systems are vital and key to sustain our way of life. And these resources, these water resources, is under tremendous amount of stress from rising population, from growing populations, through expansion of agricultures, through rapidly growing economy. And this is also under tremendous stress from climate change, which is actually threatening the sustainability, the very sustainability of a system that we rely on to sustain our way of life. So then I just wanted to go back to the things that have made our planet so sustainable, and what is that we have done to this planet that is making all these kind of problems. When you talk about different kind of processes, the water cycle processes, the carbon cycle, the energy cycle, all these cycles that we see in our nature, they are very, very highly efficient processes. We see the interdependency between different species. We see the adaptability. We do adapt nicely, and many plants and the animals, they do adapt to changes. But the human environment, the human environment, the development in human system, the human environment system, that has threatened this very basic natural processes that are key to our sustainability. We would see forests, which are actually the water factory of our planet. And you can see here they are significantly decreasing, and they have decreased significantly over the period of time. We see the same trend in US, in Europe and other countries as well. The forest has been decreasing significantly. And these resources, they regulate water, they recycle water, they clean water, and then they do all different kind of ecosystem services. And our activities our need to actually produce food to feed rising population has again has a significant impact on these very important water factories that we rely on. Our activities, human activities, has also again the stress to support this rising population, to support the growing economy, has had a very significant impact on Laos River Basin across the globe. The figure what you see here is most of these river basin on the red, they never are not connected to the ocean. They have lost their connection to the ocean. So these are natural processes because of our anthropogenic activities and other different sources. These rivers, they are actually not connected to the ocean anymore, meaning that they have more demand than the resources that is available in this kind of system. And having this scarcity is not only about the water availability, but it is also going to affect the health and hygiene and other things, because water is a fundamental resources that we rely on for our survival, not only about our survival, but also the survival of ecosystem. So this is the study done by this World Resource Institute working paper, and they try to quantify the amount of investment that we need to make to improve our infrastructure so that we can get to that sustainable water management level, so that we sustain our water resources, we minimize those imbalances that we see in our demand and supply of water. And you see in US, the cost, the investment that we need to make is somewhere around less than 2% of our GDP. However, this amount varies significantly from country to country. And if you further break down the water scarcity is the demand is increasing and then supply is reducing, or the quality of supply is going down. And that is a scarcity. In order to address that challenge coming from scarcity, that total amount of investment would go, 67% of that investment would go towards solving that scarcity problems. And then if you go to different sector-wise, again, you can have a water scarcity effect on industries and then the agricultures. It is much more cheaper to invest on the structures and tools that would address the water scarcity in the agricultural field than in the industrial field, because we need different tools to address the water scarcity in different sectors. And what you are seeing here is the ASC report card for the Louisiana infrastructure for water supply. And we need immediate attention. Louisiana's infrastructure needs immediate attention. It has received this D- grade. And what are the tools we have in order to balance this demand and supply? We can look at the supply side of it. We can also look at the demand side of it. But again, there has been significant advancements in different types of technologies. You'd see there is a great advancement in biomimicry and different kinds of technologies that can be used to generate new supply of water. We can go with constructing storage dams and diversion structures, the conventional way of providing water supplies. And we can also use the trade approaches like virtual water to increase our supply. On the demand side, again, these are again some typical examples that you would see. The use of Namibian beetles. Again, they are very efficient at generating water even in a dry desert. And based on those technology, some farm in California, they produce sun to water system that produces 40 to 100 grams per day of water in a dry environment. There are cloud seeding technologies. There are technologies that convert importable water into potable water, like desalinizations. And then we have a conventional structures like dams and diversion structures that help us build the supply side of the water. And by increasing supply side, we can minimize the gap that we have between the supply and the demand of these vital resources. On the demand side, we can focus on improving efficiencies. We can focus on improving conservations, and we can also focus on the demand response side of it. Using water sense fixtures, efficient fixtures are way of improving our water efficiency. Not only water efficiency, in some cases, they also help us save energy. And saving energy is the other way of, again, saving our climate. And then again, there are other benefits that we have. We lose our distribution systems and mains lose significant amount of water. That amount can be conserved by using good, nice technology. And then we can also reduce our consumptions, especially when demand goes down, by integrating technology in our systems. So these are some of the tools that we can implement in order to bridge the gap that exists between this demand and the supply. And then climate change adds this, again, imbalances that the balance between the demand and supply. So again, I'm not going to go and talk. Lindsay, she put together in detail about different mitigations and adaptation strategies. Mitigations, these are the set of tools and strategies that we have that minimizes the emissions. That is a prime cause of climate change, whereas adaptations are the tools that help us adapt to changing environment. In whatever tools that we use, water has to be the key resources, both an adaptation or both also in the mitigations. If you look in mitigation, the mitigation is, again, we try to use technology that emit less greenhouse gas emissions. So if you look at the table on the left, what you see here is from the top, the petroleum. These resources, they have a greatest carbon footprint. And as you go down, the carbon footprint decreases. But if you look on the column on the right, what you see here is as the carbon footprint decreases, the water footprint increases. So what it is essentially saying is that if you want to mitigate the climate change effect, then we would need extra water, not only to feed our ecosystem and a public and other food and energy system, but also to mitigate against changing climate, we would need extra water. So that's why water is the key resources that we would need even to counteract the climate change. So this figure here, you see the carbon footprint for different sources of energy. For coal, you have a largest carbon footprint, and then you would see the nuclear, hydropowers, they have a smaller carbon footprint. But if you look at the land use footprint, then again, you would see the nuclear, it has the smallest footprint, land use footprint, whereas hydro and solar, they do have, even though they have a smaller carbon footprint, but their land use footprint can be significant. And then if you look at the water footprint, the nuclear, which was smaller in the land use footprint, smaller in carbon footprint, had the largest water footprint. So this also shows the point that I was making, that is we would need water to mitigate the climate change impact. Talking about the imbalances that we have in water system in Louisiana, the water is used predominantly by these 5 different sectors. Industries and powers, they mostly use surface water, whereas irrigation, public, and then aquaculture, they tend to use more water withdrawn from the groundwater resources. So both of these resources are, as again, a very important tool, resources which will help us adapt to changing climate. Talking about the supply and demand side, the tools that Louisiana might have, these are some of the tools that I thought of about. In the supply side, there is a produced water, we have deep groundwaters, ecosystem restorations, marine protein, the virtual water. These are some of the tools that state has been using and has the potential to use it in order to address those imbalance between supply and demand. Again, in the demand side, conservation and management, and that's always the key. Low-hanging fruit, cost-effective and less expensive as compared to the supply side approaches, which tend to be a little bit more costlier. Talking about the produced water, this used to be a nuisance in the past, but now they can be considered as an environmental asset. The water that's coming out from oil and gas produced within Louisiana can be used for a range of different purposes. And again, saving water would help us adapt. It will also help us mitigate the impact of climate change. So I'm just trying to talk about different ways and sources that we can save water or collect water and address those climate change impact. So this is a map showing the produced water potential within US, and you can see the amount of produced water potential within Louisiana, within this Huntsville region. You would see it's almost equal to the irrigation water requirement. So that's a huge potential using produced water if it is treated properly. Again, there's the big if there in using the produced water for many other proper purposes. It has to be treated properly. It has to be fit for purpose. The another areas that the Louisiana can think about is the using of geothermal potential. The temperature at 15,000 feet down along most of Louisiana's coastal plain is hot enough for energy productions. And because we have existing drillings for hydrocarbons, we can think of using this produce hot water to for the productions of electricity, the production of heat. This is again the table that I've taken it. This shows that the geothermal power from existing Gulf Coast hydrocarbon productions for Louisiana, depending upon different temperature, the values are different, but you would see there is significant amount of potential that we have. And this is again a cleaner energy. It can produce again, use water, and it has a lower carbon footprint. The another resources, key resources that we have is the groundwater resources, and these resources is depleting in major regional aquifers, as you see in Louisiana. This has been decreasing and declining over the period of time. And the implication of this depletion of groundwater is, again, the drying of wells, reduction in water in streams and lakes. It might result in land subsidence in many regions, and overall decrease the water quality and within the aquifer. And when this water table goes down, how do we address that problem? We address that problem by even going deeper down. And this recent study, recently published study, found out that the Americans are drilling deeper than ever for fresh water. The figure on the left shows the groundwater uses for different sectors. You would see in Louisiana, it's predominantly it's used by industries and the power sectors. And if you look at this figure on the left bottom figure shows the depth of groundwaters. Bluer the area, deeper the groundwater well that we have. And then the figure on the right shows the trend in the depth. It shows that the drilling is the oil are becoming deeper and deeper. They are going deeper and deeper, partly because you will have greater access to those valuable resources. But then on the other side, there will be more energy consumptions because you'll have to pull water from deeper groundwater as a brackish. They will need to more treatment if you want to use it. So there are other environmental impact to it. So going deeper may not always be a sustainable way in using these resources. And then deepening groundwaters may also drive the intrusion of salt water into our coastal land. As you can see here, most of the oil, the ground well, which is based on 250,000 tube wells data across the coastal area, it shows that most of these areas, they are deeper than the seawater level. So when we have that gradient, then it's going to drive that water, the salt water is going towards the groundwater, and then we would lose the value of the resources that we already had. And we would need to implement good and robust groundwater management tools, and these are some of the list again. And then the other important point about saving the water is this recent study. They concluded that future water saving can be increased by using marine fish consumption, because terrestrial protein has a very high water footprint. It consumes around 22.13 gallons per protein gram. And when you use a marine protein, then we can save that water because we don't need the freshwater systems. So that's one way of saving waters. This is an estimate from that study that looked into the increase in the water footprint if we don't use marine protein in our food system. And you can see there is a significant rise in the water footprint if we take the marine protein out of the consumptions. And then again, talking about the Louisiana coast, we have this dead zone conditions with all these different kind of nutrients coming from Atchafalaya and Mississippi rivers, polluting our river bodies. If we restore our ecosystem, if we improve this ecosystem, then we might again potentially uh, shave some fresh waters through proper ecosystem, terrestrial ecosystem, or coastal ecosystem restorations. This is again Lindsay in her presentation. She put very nicely carbon sink on coastal wetland. This is a tremendously big amount, as you see here, as compared to tropical forest and boreal forest. The salt marshes and mangroves and seagrasses, they potentially can capture and bury more carbon than those typical ecosystems. And since we have a lot of this marsh soil in Louisiana, they can really drive these carbon sinks in coastal land. And this is not only about the adaptation, this is also about mitigation. Being able to store those carbon in our soil is going to be, we'll have less emissions, and at the same time, it's also going to make the ecosystem more resilient. I think so. Coastal restoration activities, they're critical because they not only provide adaptive approach, they also are a mitigative approach against the changing climate. And then the water footprint for crop productions. This is again based on the presumptions that the water efficiency used in different part of the countries, they are not same. The water we use in Middle East, the efficiency of water used in Middle East is very different from the water use efficiency in the Southeast China and Southeast Asia. Again, the efficiency are different. This figure here shows the water footprint for crop productions, and you would see the red means unsustainable. The more water is used for a given crop yield, and greener means they are more sustainable. And from this realization, again, we can have trade, virtual water trade, and to some extent, using this global trade of goods can also be used as a tool to address the water crisis that we may face going forward. So talking about the solutions that can curb climate change and help us adapt, we do have a couple of very interesting options that can help us mitigate the impact of climate change, but at the same time also help us adapt towards these issues. So I think it's a good, we can look into the alternate water sources, look into water and energy conservations. I think, and to the end, then I would say is greater awareness of energy, carbon, and water issues can lead to adoption of tried and tested of newly innovative ideas, and is key towards holistic approach to water and carbon footprint. So I would say the greater awareness of water and carbon and water issues is critical if we want to succeed in this. So I would say if anybody and all of you listening to these presentations, there are wonderful tools available in the website developed by some by EPA, some by DOE, and you can look at those tools, evaluate your water use patterns, look at how you are using and consuming water and energy, and make yourself aware about those possibilities and opportunities, and that you can contribute meaningfully in terms of conserving water and energy. And by doing that, I mean, we would need to do something from the sustainable point of view. And we can start that with by simply making yourself aware of those different options that are available, those methods that are tried by many peoples, that works for everybody. And by knowing all those tools, we can do little bit things in our life that can have a very lasting and significant changes to our environment. I think that's all that's all I have from here.
Thank you, Dr. Bastola, for your presentation and for bringing us about awareness about water and how important. I think many people, they do a carbon footprint, and it's hard to see this number, but when we do a water footprint, I personally did it a couple times before, and you can really see the difference. So thank you so much